So, welcome students for the physical chemistry lecture, paper number 11. Up till now, in the electrochemistry, you have studied in detail what is anode, what is cathode, what is the salt bridge, and anode and cathode, they are combined with the help of salt bridge, and this forms a electrochemical cell. Again, in detail, you have studied the Daniell cell. Then the next point, here it is, types of electrodes. And for your study, in all, there are 5 types of electrodes. The first type, it is the metal ion electrode, gas electrode. And in this, for your study, there are 2 electrodes, hydrogen gas electrode, chlorine gas electrode, oxygen gas electrode. And the next electrode, it is metal insoluble salt electrode. That is the metal, it is in contact with its sparingly salt. So that electrode, it is called as metal insoluble salt electrode. And the last type, it is the redox electrode, that is oxidation reduction electrode. At first, we will see what is the metal ion electrode. Here, see metal ion electrode. The first type of electrode, it is the metal ion electrode. That means any metal when it is in contact with its solution. Suppose for example, we have a zinc rod, and when it is dipped in the solution containing ZnSO4, that means that solution contains Zn++ ions, and this combination, it is called as metal ion electrode. Here in this case, the metal strip is kept in contact with the solution of a water soluble salt containing cation of the same metal. And for example, here Zn, it is in contact with Zn++ ions, or copper when it is dipped in copper sulfate solution, it forms a copper ion metal electrode, or zinc ion electrode. Then in the electrochemical cell, the electrode having higher oxidation potential undergoes oxidation and acts as an anode or negative electrode, and the electrode having lower oxidation potential undergoes the reduction and acts as a cathode or positive electrode. Here zinc ion electrode, it is represented like this. At first the solid phase, then vertical line, and then the solution phase. Here Zn++, and these are in a aqueous medium. So here they have written aqueous. This is the representation of metal ion electrode. Any metal when it is in contact with its solution, this forms the metal ion electrode. Then the half cell reaction, it is written as like this. Zn, it dissolves, it gives Zn++ ions in the aqueous medium plus 2 electrons, and this process we call it as a oxidation process. And when we have write here Zn++ ions plus 2 electrons, it gives Zn. That means this is the reduction process. Here the loss of electron means oxidation, and the gain of electron, that means when Zn++ ions, they absorbs or they pick up the 2 electrons, that is the gain of electron. And we have, this is the reduced state of the metal, and this one Zn++, it is the oxidized state of the metal. here. Then the copper ion electrode, here it is represented as like this: Cu in a bracket S, vertical line, Cu++ ions in aqueous medium. Here the oxidation reaction taking place at a copper electrode, it is written as Cu solid, that means metal electrode. It dissolves, it gives Cu++ ions plus 2 electrons. This is the oxidation reaction. And the reduction reaction, it is written as Cu++ in aqueous medium plus 2 electrons, it gives Cu, and this is the reduced phase of the metal. This one is the oxidized phase of the metal. And with the help of Nernst equation, we can write the Emf equation as, suppose for example, Ezn, it is equal to E0Zn minus 2.303 RT upon 2F into log activity of Zn++ ions. And in case of copper ion electrode, we can write the EMF equation for Cu, that is ECu, it is equal to E0 Cu minus 2.303 RT upon again 2F, the number of electrons involved here, it is 2. Therefore 2F into log activity of Cu++. And these are the equations. हॅलो, हा, लेक्चर करते, परत करते फोन. हा, अगं परत करते. हा, हाय की. का नाही नाही, आपल्याला काय नाही, काल सुट्टी होती. ओके, लेक्चर करायला लागले, परत करते. हा, जाऊया 11 वाजता. हा. Then we will see the gas electrode here. Gas electrode. A gas electrode consists of gas, for example H2 gas, Cl2 gas, O2 gas, in contact with a solution containing ions derived from the gas, for example H plus ions, Cl minus ions, or OH minus ions. The potential of the gas electrode depends upon the concentration of its ions in the solution and the pressure of the gas. A gas electrode consists of gas bubbled about inert metal wire, and that is always platinized platinum electrode immersed in a solution containing ions with which the gas is reversible. And in the last lecture, I have explained you the hydrogen gas electrode. Here, the platinum used as a conductor and to absorb the gas. For example, here standard hydrogen electrode. Here, the standard hydrogen electrode, it is represented as PT, vertical line, H2 gas at 1 atmospheric pressure, and hole, it is in contact with solution containing H plus ions. And when the concentration of H plus ions, it is unit, that is 1 molar, we call, and the pressure of the gas, it is 1 atmospheric pressure, that so that we will say this electrode is standard hydrogen electrode. Here we have taken the pressure of the gas, it is 1 atmospheric pressure, and the concentration of H plus ions, it is 1 molar. Therefore, this electrode is called as the standard hydrogen electrode. Remember well, the standard hydrogen electrode, it is abbreviated as capital SHE, where SHE, it is the standard hydrogen electrode, and it is represented as PT oblique line H2 at the base there is a gas. This G indicates H2 is gas, and in bracket here it's a pressure. Then vertical line, and here it is H plus ions in aqueous medium, and here in bracket there is a concentration of H plus ions. Then the half cell reaction, it is written as H2 gas, it gives 2H plus ions in aqueous medium plus 2 electrons, and this is the oxidation reaction. And when the reduction reaction, we can write here as 2H plus in aqueous medium plus 2 electrons, it gives H2 gas. This is the reduced phase of hydrogen gas. H2 is a reduced phase, while H plus it is a oxidized phase. Then the electrode potential is arbitrarily taken as 0. We have seen last lecture. Then we will see here the chlorine gas and the construction of chlorine gas. Here the chlorine gas at 1 atmospheric pressure, it is bubbled at a platinized platinum, and whole it is in a contact with solution containing Cl minus ions, and again the concentration of the Cl minus ions, it is here 1 molar. This is the representation of chlorine gas electrode. Here platinum oblique line, Cl2 gas at 1 atmospheric pressure, oblique line, here Cl minus ions in aqueous medium, and the concentration of Cl minus ions. Then the half cell reactions, here we can write Cl minus to Cl minus, it gives the Cl2 plus 2 electrons, and this is the oxidation reaction. And here Cl2 gas plus 2 electrons, it gives 2 Cl minus. Remember here Cl minus, it is a reduced state, while Cl2 it is a oxidized state, and by using either this equation or this equation, we can write the Nernst equation for electrode potential. And then we will see the oxygen gas electrode. Here oxygen gas electrode is represented as PT oblique line H2 gas at 1 atmospheric pressure, and it is in contact with solution containing OH minus ions, and concentration of OH minus ions, it is again unit or 1 molar. And the half cell reaction is represented as here 4 OH minus, it gives 2 H2O plus O2 plus 4 electrons, and this is the oxidation reaction. And here 2 H2O plus O2 plus 4 electrons, it gives 4 OH minus. This is the reduction reaction, and again we can write the Emf equation for the oxygen gas electrode. Then the next point, here it is metal insoluble salt electrode, that is the calomel electrode, and I have explained you in a detail the construction of calomel electrode. Here metal insoluble salt electrode, it is reversible anion electrode, is also called as metal sparingly soluble salt electrode, and in this electrode a metal and its insoluble salt of the metal in equilibrium with a solution containing the same anion as the sparingly soluble salt electrode, and for example calomel electrode. You have studied in a detail the construction of calomel electrode. Thank you.